Good morning to all. Students, ओमकार सुरवशे, वैष्णवी मुरली, आकांक्षा नाडे, श्रद्धा, राधा, भोसले. Okay, see here. Today in this live lecture we shall learn how to take the product of two integrals with respect to separate or different derivatives. Also, we shall study how to calculate the value of gamma positive fraction, negative fractional number. That means, first of all, we have to prove the important theorem, that is gamma 1 by 2. How to calculate the value of gamma 1 by 2? One standard result which we have to prove today. And that standard result is regarding how to calculate the value of gamma 1 by 2, and by using that gamma 1 by 2 we can find the solution of gamma non-integer positive and negative numbers. We shall discuss today. Okay, actually we have to find out product of two integrals and value of gamma 1 by 2. These two bits which we have to study in the today's lecture. Okay, then tomorrow we shall move towards the beta function. Now actually we know that according to the definition of the gamma function, it is the special function, and which is defined as gamma n is equals to integral from 0 to infinity e raised to minus x into x raised to n minus 1 dx, and n is greater than 0. This is the particular type of integral, or it is also called as a special function, or it is also called as a Eulerian integral of second kind. We can write gamma function in the different integral, in the different ways, with respect to x, with respect to y, with respect to t. That means we can use integration with respect to x, integration with respect to y, integration with respect to t. Also, we have proved some basic properties of the gamma function in the last lecture. Also, we have proved the transformations of a gamma function. We can write this in the transformation of the gamma function. Okay, now today, see this. Today we shall discuss the graph of the gamma function. How to draw the graph of gamma functions here. Actually, we know that yesterday we have seen the value of gamma 1. Who can tell me, student, sanga bare value of gamma 1 kiti aste? Value of gamma, suppose this is x-axis, this is a y-axis. We can write 1 minute. Suppose this is x-axis, suppose this is y-axis. See this is a x-axis, this is a y-axis. Now we have to plot the graph of a gamma function. How to plot the graph of a gamma function? Actually, these red lines which denotes the graph of a gamma function. But how we can plot the graph of a gamma functions here? You know that gamma 1, chala re student, very good. Gamma 1 ची व्हॅल्यू किती, gamma 2 ची व्हॅल्यू किती, gamma 3 ची व्हॅल्यू किती, आणि gamma 4 ची व्हॅल्यू किती प्रत्येकाने सांगायचे. So now see here, yesterday we have seen the value of gamma 1 means 1. Gamma 2, how we can calculate the value of gamma 2? 2 minus 1 factorial means 1 factorial, that is gamma 2 is also 1. Then we have to calculate gamma 3. So we can write the value of gamma 1. What is the value of gamma 1? Gamma 1 is equals to 1. Gamma 2, which is equals to 1, again 1. Gamma 3, which is equals to, gamma 3 means gamma n minus 1 factorial, 3 minus 1 factorial means 2 factorial, 2 factorial means again 2. Gamma 4, okay. Gamma 4, what is the value of gamma 4? You know that this, gamma 4 means 3 factorial, 3 factorial means 6. Gamma 5, means 4 factorial. 4 means 24. Okay, so these are the positive values regarding the gamma function, positive integers regarding the gamma function. Also, you know that the negative value, can you tell me what is the value of gamma 0? Also, gamma 0, that is the infinity, that tends to infinity. Again, we know that gamma minus 1, that is again tends to infinity. Okay, so gamma minus 2 again tends to infinity. We know that this gamma of a negative integer, which is always tends to infinity, it may be tends to the positive infinity, it may be tends to the negative infinity, it is no problem. We shall discuss this later on in detail. We shall discuss the concept later on, positive and negative infinity. Okay, now our aim is to plot the graph of a gamma function. Now see here student, check this, we can write here. Now see here, gamma 1, suppose this is a 1, x-axis 1, value of gamma 1 is 1, so 1 comma 1, this is the point, first point. Gamma 2, when x is equals to 2, or we can write this n also, then y is equals to means f of x is equals to 1, again value of gamma 2 is 1. So gamma 3 is 2, okay, suppose this is 1, this is 2, this is 3, this is 4, so it will be 3. It will be the 2, gamma 3 is 2. Gamma 4 is 6. Gamma 0 is infinity, it will be the infinity, but it is not. So we can plot the gamma function in the positive quadrant. How we can plot the gamma function in the positive quadrant? We have to join all these points. In this way, we will get the graph. This is the infinity towards when x tends to infinity, when x tends to 0, then gamma tends to infinity. This is a very important. So this is the graph of a gamma function in the first quadrant. Now we shall move towards in the negative part. We know that the value of gamma 0, जेव्हा 0 असतो, for x is equals to 0, then the value of gamma 0 is infinity. That means it is up to the infinity. Okay, if we take x is equals to minus 1, then it will be the infinity. So we will not get a point on the function, because as x tends to minus 1, then it tends to infinity. So we can't define that point on a graph. When x is equals to minus 2, then that point will be at infinity. So that point will be at infinity. We can't draw that point, but that point will be the infinity in this way, out of the graph. That point will be the infinity. So for the negative integers, the value of gamma is up to the infinity. But we can find the value of, see this is very important, but we can find the values of gamma non-integer negative and positive numbers also. So for non-integers, we can write in this way. We will get the graph. We shall see how to draw this graph. For the negative non-integer numbers, the graph will be in this way. This is eyes like this. This is eyes like this. Means the negative integers, in between the negative non-integers minus 1 to minus 2, the values of gamma will be like eyes like this. In between 0 to minus 1, the values of negative non-integers like in this way. So we can plot this graph by taking the non-integers negative numbers. We can define the gamma function, but for the negative integers 1 minus 2 minus 3 we can't define the gamma function. Okay, now how we can find the values of negative and positive non-integer numbers whose gamma function which we have to define. Okay, so there is one important result which we have to prove, that is a gamma 1 by 2 is equals to root pi, and then we can find these types of graphs. Okay, now first we shall move towards one important theorem, that is a product of two integrals. How we can take the product of two integrals we shall discuss here in this section. Okay, I shall write direct theorem, product of two integrals. Prove that integral from a to b f of x dx into integral from c to d g of y dy, which will be integral from a to b double integral from c to d f of x into g of x dx dy. We have to prove this. Double integral from a to b into c to d, integral from a to b, double integral from a to b, c to d, f of x into g of x dx dy. So we have to prove this result. This is the theorem which we have to prove. This theorem is also important theorem, that is a product of two integrals. First integral is integral from a to b f of x dx. This is integration with respect to x. The second integration is integral from a to b g of x dx. Both are the separate different limits. Then we have to find out the product of two integrals, that is which we have to prove integral from a to b, double integral from a to b, c to d, f of x dx, g of x dx. Okay, now we shall move towards the proof. Okay, now we shall consider, suppose that the value of integral of g of x is capital G of x. Suppose let integral of g of y, we shall consider integral of g of y dy, which is equals to capital G of y. We have considered integral of small g is a capital G. Then we can define integral from c to d small g of y dy. How we can write, student? Student, now you tell me. Rutuja Deshmukh, Varshali Khare, Murli Dubey, Sainath. How we can write this integral? So we can define this integral, that is equals to g capital G of y over the limit c to d. That means we have to put upper limit g of d minus g of c. So suppose this is equation number 1. Now actually we have to prove that integral from a to b f of x dx, integral from c to d g of y dy, which will be double integral from a to b c to d f of x into g of x dx dy with respect to x, with respect to y. Okay, that is, this type of integral is called as a double integral with respect to x and with respect to y. Okay, so now we shall take this double integral from a to b integral from C to D. Now we shall consider this double integral A to B, C to D. That means we can take RHS. Easily we can take RHS. Now RHS, which will be double integral from A to B, C to D. We can write f of x into g of x, g of y, dx into dy. Now, in the double integral, we can operate integration one by one. We can operate integration one by one here. Okay, so we can take integral. We know that integral of g of y with respect to y. Yeah, g of y's integration with respect to y, we know. And what is that integral of g of y with respect to y? So we can write integral from, यालाच असं सुद्धा लिहितात, integral from a to b f of x into integral from c to d g of y dy dx. Only we have distributed integration. Now we know that integral of g of y dy, which is equals to, so integral from a to b f of x into g of capital G of y, because integration of small g is capital G of y from c to d. Again dx size it is. Integration of small g of y dy is capital G of y, so it can be written as g of a. So we can write a to b f of x into g of d minus g of c, again dx. You know that what you have to know, g of d is a constant. Suppose I shall write here, suppose g of x is equals to 2x plus 1. Okay, now g of x from 2 to 3, then we can write 2x plus 1 from 2 to 3. So we have to put 2 into 3 plus 1 minus 2 into 2 plus 1. If we put upper limit and lower limit, then we will get 7 minus 5, that will be 2. So this term will be constant. That means we can say that g of d minus g of c, it must be constant. So we can take out of integral. If there is any constant term with respect to x, then we can take out of integral. So we can write integral from a to b f of x dx into, we can write this as g of d minus g of c. This is the constant term we can take out of integral. But from equation 1, we can write g of d minus g of c, means it is the integral from c to d g of y dy. So we can write this as integral from a to b f of x dx into, as it is, this value is called as integral from c to d g small g of y dy. This is a from 1. Is it okay? And which will be the RHS, which is equals to LHS. Therefore, we can say that, therefore LHS, RHS equals to LHS. Therefore, integral from A to B. So we can write integral from A to B f of x dx into integral from C to D g of x dx, which will be double integral from A to B C to D f of x into g of x dx dy. Okay, so henceforth, and this completes the proof of this theorem. This is called as a product of two integrals which are in the different variable forms. So integral from A to B f of x dx, we have to prove integral from A to B f of x dx into integral from C to D g of y dy. We can write double integral from A to B C to D f of x into g of x into dx dy with respect to x with respect to y. Suppose that this integration of small g is capital G, so we can write definite integral from C to D, capital G of D minus capital G of C. Now we consider RHS. In that RHS, there is a product in between two functions. They are having a different variables, so we can take integration one by one. तर आपण सुरुवातीला जी वाय चा विथ रिस्पेक्ट टू वाय इंटिग्रेशन घेतला सी टू डी जी ऑफ वाय डी वाय. So we can write, this can be written in this way, g of y dy according to our supposition, small g of y integration capital G of y. So put upper limit, lower limit. After substitution of upper limit, lower limit, that term will be constant. If the term is a constant, then we can take out of integration. So we can take out of integration. In separate integration pasan. Integration, you have to separate that from the integration. Integral from A to B f of x dx now separated into g of d minus g of c. But g of d minus g of c means integral from C to D g of y dr, which will get the LHS. That means thus we can say LHS is equals to RHS. That means this proved. Is it okay? समझला करे? Yes. If you have any doubt, then you can ask me. Now we shall move towards the second important theorem. Directly we shall move towards the second important theorem. आता आपण दुसऱ्या सेकंड ज्या महत्वाचा थेरम आहे त्याच्याकडे आपण जाऊ. सेकंड हेडिंग काय? व्हॅल्यू ऑफ gamma 1 by 2. How to calculate the value of gamma 1 by 2 we shall discuss here. For this purpose we have to prove one theorem. That theorem is so. Prove that gamma 1 by 2 which is equals to root pi. So this is also important theorem. This is also one theorem you have to do. हा सुद्धा theorem तुम्हाला करायचे. This is also theorem. हे पण important आहे. Prove that. So इथं पण वाटलं तर theorem लिहा रे. So we have to prove, what we have to prove? Gamma of 1 by 2 which is equals to root pi. This is a very important theorem. This is a very important theorem. Actually we have to find out the gamma 1 by 2 and gamma 1 by 2. That means, actually see this in the graph. Gamma 1 by 2. Say this 1 minute. Gamma 1 by 2. This is 1 by 2. So we can write this as gamma 1 by 2. Means this point will be root pi. We have to prove this result. Gamma 1 by 2 means root pi. Now you calculate. By using the calculator, you calculate the approximate value of gamma 1 by 2. Okay, so root pi, root मध्ये pi ची व्हॅल्यू ठेवून काढा म्हणजे तुम्हाला approximate value मिळेल. Proof. Now we shall move towards the proof. proof. Say this. Now we know that the gamma function we have, by the definition of a gamma function, how we can write here, students? By the definition of gamma function, gamma of n, which can be written as integral from 0 to infinity, suppose e raised to minus t into t raised to n minus 1 dt. We shall write this first. Okay. Now, very good, Srinath. Now we have to convert this into the by using a proper substitution. Actually, we have to find out the value of gamma 1 by 2, because this is the formula for gamma n. This is the formula for gamma n. But we need gamma 1 by 2. So gamma 1 by 2, which will be integral from 0 to infinity e raised to minus t into t raised to 1 by 2 minus 1. That means in place of n, we have to put 1 by 2 dt. So we can write integral from 0 to infinity e raised to minus t into t raised to minus 1 by 2 dt. Is it okay? 1 by 2 minus 1 म्हणजेच 1 by 2 येतो स्टुडंट. Is it okay? समजतंय का पहा. Now our aim is to solve this integration. Our aim is to solve this integration. Now see this. This is the square root. T raised to 1 by 2 means actually 1 upon root t. So remove this root t raised to 1 by 2. To remove this fractional power, we have to put t is equals to x square. So this is the gamma 1 by 2. Put t is equals to x square. So how we can write? Therefore, dt is equals to 2x dx. So dt upon 2 is equals to, we can write this as dt upon 2 is equals to x dx. Okay, no problem, x dx. अरे राहू द्या, काय अडचण नाही. 2b असला तर काय अडचण नाही. 2x dx. ओके. आता लिमिट्स चेंज होतील. नाउ वी शॅल मूव टुवर्ड्स द लिमिट्स. Limits when lower limit t is equals to 0. Actually this integral is in the variable t. So lower limit is for t, upper limit is for t. Now we have to convert into the x. So we have to find out the lower limit and upper limit in terms of x. When t is equals to 0, then x is equals to 0. And when t is equals to infinity, then x is equals to infinity. Actually x is equals to, यहाँ पे अगर x t is equals to infinity अगर लिखा है तो भी, that means t tends to infinity, x tends to infinity. I have told you many times, if there is infinity in the equation, then you have to say it tends to infinity. Meaning of that is, t is equals to infinity means it is not a perfect value. It tends to infinity. That means as t tends to infinity, then x tends to infinity. So our integral becomes, therefore, gamma of 1 by 2, which is equals to integral from 0 to infinity. Now the put t means e raised to t, means e raised to t. T means x square. So we have to put in place of t x square in the both side according to our this substitution. So t means x square bracket raised to minus 1 by 2. Again we can write dt means 2x dx. Dt means 2x dx. So gamma 1 by 2, which will be काय तर पहा, integral from 0 to infinity e raised to minus x square into x raised to minus 1 into x into dx, and we can take these two out of integral. Take these two out of integral, 2 will be get cancelled, x raised to minus 1 into x raised to 1. So what is the value of x raised to minus 1 into x raised to minus 1 into x raised to 1? That raised to x raised to 0, it will be 1. So we can write this integral from 0 to infinity e raised to minus x square dx. Suppose this is the equation number 1. That means this is the gamma of 1 by 2. We have written this gamma of 1 by 2 with respect to x. Similarly, we can write in terms of y. याला परत आपल्याला in terms of y लिहिता येईल. Now replacing x by y by the property of a definite integral, we can replace by the property of definite integral. By the property of definite integral. So also we can write a gamma of 1 by 2, which is equals to 2 times of integral from 0 to infinity e raised to minus y square dy. Suppose this is just equation second. This is variable change property you can use. Okay. So replace x by y, then we will get by the variable change property which we have studied in the previous chapter, that is a property number second. So now multiplying equation 1 and 2, we can multiply these two integrals. We can multiply equation 1 and 2 means we have to multiply left side, right side according to this theorem. Integration, multiplication of two integrals. Okay. So we can multiply by, see this, multiplying, so we can write multiplying equations 1 and 2 as per we have seen in the theorem. Okay, so we can write the gamma of 1 by 2 into gamma 1 by 2, which is equals to 2 integral from 0 to infinity e raised to minus x square dx into 2 times of integral from 0 to infinity e raised to minus y square dy. Is it okay? So by using a theorem, this theorem, integral from a to b f of x dx into integral from c to d g of y dy, these are the two different integrals with respect to x and with respect to y. Then according to this theorem we can multiply, we can combine this theorem in the form of a double integral. We can combine these two integrals in the form of double integral. So by using this theorem we can write 2 into 2 means 4, double integral from 0 to infinity e raised to minus x square d into e raised to minus y square dx dy. This is as per theorem on product of two integrals. We can write theorem on the product of two integrals. Now e raised to minus x square into e raised to minus y square means there is a base same. By using the index rule we can write integral from 0 to infinity, integral from 0 to infinity. We can write this as, how we can write, e raised to minus x square minus y square dx dy. So we can write 4 integral from 0 to infinity e raised to minus x square plus y square into dx into dy. This is the, now see this on the left side, gamma 1 by 2 into gamma 1 by 2. So we can write gamma 1 by 2 bracket square. So we will get the result gamma 1 by 2 bracket square. Suppose this is equation 3. Now we have to change this integral in the form of, we have to change this integral in the form of a polar. Now we can change the variables, that is x comma y, into the polar form, that is r comma theta. See this, you have drawn the graph of this function. Suppose in this way, this is the gamma function. You have know the value of a gamma function in this way. This is the gamma function. If we consider any variable point here, suppose this is a point P, we can write in the Cartesian form x comma y, or in the polar form we can write r comma theta. Then we can relate this point with respect to, suppose this is a theta, then this length is called as x, this length is called as y, then we have this length is called r. You know the polar coordinates means if P is any point having a coordinate x comma y, these coordinates are Cartesian coordinates. Its polar form is r comma theta, where r is the distance of a point P from origin. Theta is the angle made by OP with the positive direction of x-axis. That means we have to convert this Cartesian coordinate into polar coordinate. So according to the Pythagoras rule, we can directly write x square plus y square is equals to r square. So we have x is equals to r cos theta, y is equals to r sin theta. That means x square plus y square is equals to, how we can write, r square cos square theta plus r square sin square theta, that is equals to r square. That means in a place of x square plus y square we can put r square. This is the first condition. R and theta are the coordinates represented by the polar. Also, you know that this is a point P which is represented on a gamma of x. This is a function. This is a graph of a gamma of x. Now, we shall write this point, Cartesian point x comma y, into the polar coordinate means r into theta. Now also we know that we have studied this number also, dx into dy. We have studied this, which can be written in the polar form. You know that r into dr into d theta. Putting in equation. So therefore equation 3 becomes, actually we have studied in the 12th standard how to convert the variable, that is a coordinates x and y, Cartesian coordinate, into the polar coordinate. You can use the Pythagoras rule according to the diagram, or you can use this parametric form, x is equals to r cos theta, y is equals to r sin theta, then x square plus y square, which will be the r square common kada, cos square theta plus sin square theta, that will be the one. So we will get x square plus y square is equals to r square. This is one important relation between the Cartesian coordinate to polar coordinate. And also you must know that dx is equals to dx into dy is equals to dr into d theta, r into dr into d theta. We have to replace this. Now also the limits. आता आपण लिमिट्सच्या बाबतीमध्ये करू. तर ठीक आहे, we shall put this in equation here. So gamma of left side is it is gamma of 1 by 2 bracket square which is equals to double integral see this. अभी देखो सबसे इंपॉर्टेंट क्या है, we have to change the limits 0 to infinity and 0 to infinity, both are the limits with respect to x and with respect to y. Now we have to change limit for r and theta. We have to change limit r and theta. आता r and theta, how do we can check? You know that according to the definition of the gamma function, we have to consider n is greater than 0. If we write this gamma function with respect to in terms of x, then x must be greater than 0. X greater than 0. If we take x greater than 0, then P is in first quadrant. The point P is in first quadrant. And in that first quadrant, we can take angle theta from 0 to pi by 2. This is very important. So we can write this angle theta which is from 0 to pi by 2. Derivative of theta with respect to 0 to pi by 2. Okay. This is the limit of first integral which will be the 0 to pi by 2. Here kasala, we can take theta because here the gamma of x means value of, according to the definition of the gamma function, x is greater than 0. That means we can take x greater than 0. X greater than 0. If we take the x greater than 0, then this graph is completely lies in first quadrant. If graph is totally lies in first quadrant, then we can take any point P variable on that graph. That point P which is always lies in the first quadrant, therefore there should be the possibility of theta which is from 0 to pi by 2, because in the first quadrant the value of theta is lies between 0 to pi by 2. So we can take the limit of theta. We have to convert dx dy into r dr d theta. So theta will be 0 to pi by 2. Now we can take value of r. If x tends to 0, then gamma x tends to infinity. That means it tends to infinity. That means P point tends to infinity when x tends to 0. So r means length of point P, 2o. So this point P is a variable. When x tends to 0, then gamma x tends to infinity. That means point P tends to infinity. If a point P tends to infinity, then OP tends to infinity. That means R tends to infinity. So R can be written as a 0 to infinity. These are the limits. Okay, no problem. अभी यहाँ पे क्या लिखना है देखो, ये हो गया लिमिट्स के बारे में, 3 में पुट करना है e raised to x square plus y square, that means e raised to minus x square plus y square, we can write r square. Is it okay? So we can write e raised to x square plus y square, and according to the definition of the condition of the conversion of the replacement, that is Cartesian coordinate to the polar coordinate, then the value of dx into dy which is equals to r dr into d theta. We have studied this in the 12th standard also. Now we have to solve this integral. So we can write according to the theorem, we have to solve this integral. Separate this integral for r and e raised to, so this 4i is it is. Okay. Now we have to separate this integral. We have to distribute this integral separately to solve integration with respect to r, because the value of r is from 0 to infinity. So first of all we have to calculate the integral of r. Okay, now this 4 we can distribute into the two part, that is 2 into 2. So we can write this integral as gamma of 1 by 2 bracket square, which will be 2 times of integral from 0 to infinity. Now we have to distribute this integral of, first integral with respect to theta is 0 to pi by 2. Second integral with respect to r is 0 to infinity e raised to minus r square into हे 2 आत घेतला, actually इथं 4 होता, this 4 is replaced in terms of 2 into 2r dr, see this, into d theta as it is. Actually we know that the formula, what is that formula? You can write here, formula of the integral from e raised to f of x into f dash of x dx. See this, e raised to f of x into f dash of x dx. If we put t is equals to f of x, then dt is equals to f dash of x dx, there will be e raised to t dt, then its integral we can write e raised to f of x. See this, this is the value of integral. We can write a particular formula or method, this is the method. So see this, here in this case there is a r square, derivative of r square is 2r dr, derivative of r square is 2r, and with respect to dr, so we can write this integral according to this definition, 2 integral from 0 to pi by 2, we can write this as e raised to आता मायनस असल्यामुळं e raised to minus r square. See this, e raised to f of x divided by coefficient of f of x, that is a minus 1 over the limit 0 to infinity d theta. इथं minus 1 आहे ना, त्यामुळे divide by minus 1 घेतला, लक्षात ठेवा. We have to take this divide by minus 1. According to this formula we can replace this e raised to r square चा derivative 2r आहे, means e raised to f of x into f dash of x dx, then we can write e raised to f of x. Okay, so we can write this. Now put the upper limit and lower limit. आता इथं तुम्ही काय करू शकता, अप्पर लिमिट लोअर लिमिट ठेवू शकता, इंटिग्रल फ्रॉम 0 to pi by 2. So we can write this in the upper limit and lower limit, minus, keep this as it is, e raised to minus r square means 1 upon e raised to r square over the limit 0 to infinity d theta. In that integral, so we can write this. So 2 times of integral from 0 to pi by 2. Put this upper limit and lower limit. That is a minus. Okay, I shall write this minus here. Upper limit काय येतो पहा. So we can write upper limit is 1 upon e raised to infinity. That means 0 minus lower limit means e raised to 0 d theta. Now e raised to 1 upon e raised to infinity, that means 1 upon infinity, and you know that as n tends to infinity, 1 upon n tends to 0, so 1 upon infinity tends to 0, so it will be 2 times of integral from 0 to pi by 2 minus inner bracket 0 minus, आता इथं पहा 1 upon e raised to 0. Who can tell me what is the value of e raised to 0? Value of e raised to 0 is 1. So minus 1. into d theta. That means 2 times of integral from 0 to pi by 2, 1 yata d theta. So this is the gamma of 1 by 2 bracket square. So 2 times of d theta चा integration येतं theta from 0 to pi by 2. बरोबर आहे का रे? आन्सर प्रत्येकाने द्या. चला, ज्यांचे आन्सर देतात त्यांचीच प्रेझेंटी घ्या. प्रेझेंटी टाकून विनाकारण जात असतील तर त्यांना नाही एक्झामला बसू दिलं जाणार. ठीक आहे. नाव पुट द अप्पर लिमिट अँड लोअर लिमिट. 2 टाइम्स ऑफ upper limit is pi by 2 minus lower limit is 0, means 2 times of pi by 2, that will be so pi. What is the result? So we conclude that gamma of 1 by 2 bracket square, which is equals to pi, by taking a square root. So it is not necessary to by taking square root. So gamma of 1 by 2, which is equals to root pi, and hence proved. See, this is a very important result which we have proved. Very important result which we have proved. So write down this note. Note number आता आपण सुरुवातीपासून नोट मध्ये एकत्र कलेक्ट करा. How many notes are there? See this. This is the 13 number note. So we can write this note and hence proved. Hence proved. खूप इंटरेस्टिंग थेरम आहे. खूप महत्वाचा थेरम आहे. सुटसुटीत व्यवस्थित लिहा. You will be definitely understand the concept regarding this. Okay? So we can write this. काही अडचण असेल तर तुम्ही नंतर विचारा मला. If you have any doubt, then you can ask me. So we can write this 14 number note. Actually, this is the note. The important result is a gamma of 1 by 2, which we have proved root pi. 15. So actually, we know that also there is one relation. Gamma 1 by 2 is equals to 2 times of integral from 0 to infinity e raised to minus x square dx. It is equals to gamma 1 by 2. So we can write here also gamma 1 by 2 is root pi. So we shall write the another important result. 2 times of integral from 0 to infinity e raised to minus x square dx. It will be also gives a result root pi. Okay, now we can solve the problems based on this. आता याच्यावरचे आपण problems find out करू शकतो. Important result, and you must note that. See this. These are the important conversion. So this is a very important theorem. Theorem prove that root of 1 by 2, gamma 1 by 2 is equals to root pi. This is a one important result which is used to find the values of non-integer. Gamma of non-integer means gamma of 1 by 2, gamma of 3 by 2, gamma of 5 by 2, gamma of 7 by 2, gamma minus 1 by 2, gamma 3 by 2, minus 5 by 2. In this way we can calculate the value of gamma, that is the non-integer values. Okay, so we shall discuss tomorrow. Namaskar, goodbye. If you have any doubt, then you can ask me. Okay.